Welcome to this video about functional programming. So what you're going to learn then is what functional programming is, what are the benefits of functional programming, what are the uses of functional programming, and then some of the terms such as first-class object, higher order functions. We're going to look at application and partial application, and we're also going to look at function composition. So what is functional programming? Functional programming is where we actually use functions as the fundamental building block of a program. So remember, not procedures, not objects. Our statements are written as a series of functions, and each accepts some input data as an argument or parameter, and it returns an output. One main function call can actually call other individual functions. Also, each function can call another function, but it can also call itself recursively. And the function will, the idea of a function is that given an input, it will always return the same output. So a function, when you give it a specific input, it will always return the same output. So what are the key benefits of functional programs? Functional programs, often the programming requirement might be better defined as a series of functions. So some problems will actually lend themselves to be written as a series of functions instead of actually as an algorithm and as a complex series of steps. Functions can also lead to fewer errors because obviously a function will always return the same output given the same input. We can also say that functional programming code is easier to test because, again, each function should return us the exact same value every time. And it also means that no section of code can interfere with this. So the internal workings of a function are essentially hidden from every other part of the program. So writing something in functions, you can actually make it so that any error within a function will not affect any other part of the program. So you can internalize code in a function. Other benefits then is that there are no concurrency issues because no data will be modified by two threads at the same time. And also, where we use multiprocessor environments or multitasking, the sequence that the functions are evaluated in is not critical. So it's not essential to evaluate it in a set order. We can actually evaluate it in any order. So most functional programs actually use mathematical expressions. They tend to lead themselves to writing applications that require loads of calculations. They're actually used to things like improve the reliability of mobile networks. They're also used as a way to analyze large volumes of data. So functional programming can often be used to analyze big data problems. And they can also be used in sort of control systems. So specifically then, what is a function? A function is a mapping from a set of inputs to a set of possible known outputs. And there are some terms involved in this then. So the set of inputs is called the domain, and the set of outputs are called the codomain. And we can write this in a more sort of mathematical way by actually writing this. So what this actually means then is function f takes an input in the domain of A, it returns a value in the codomain of B, where B equals the value passed into the function raised by the power of 2. So a function is a mapping from a set of inputs to a set of outputs. The set of inputs are called the domain, the set of outputs are called the codomain. One of the terms that you'll come across is a first-class object. So A first-class object is any object that can be passed as an argument or the result of a function call. So functions themselves are first-class objects. And this also means that a function can be passed as an input into another function, or a function can actually be returned as the result of another function. So other objects, such as integer values, can also be passed as arguments into a function and therefore are first-class objects. So remember, a first-class object is any object that can be passed as an argument or can be given as the result of a function. So a higher order function then is a function that can take a function as its inputs or create a function as its outputs. Right, so a function that can create a function that can take a function as its input, or it can create a function as its output. So an example of this is the map command. This is a command which takes a function for input and applies it to every element in the list. So here, look, for example, here, our function is times 2, and we're going to apply this to our list of 1, 2, 3, 4, 5. Right? So this is a higher order function because our function is called map, and it actually takes, it uses a function as an input or output. So this code will actually produce the original list is 1, 2, 3, 4, 5. It will produce us a output of 2, 4, 6, 8, and 10. So map is definitely a higher order function, and the times 2 and the 1, 2, 3, 4, 5, they're all first-class objects. Okay, so we're going to look at function application. Function application is the process of providing the function with its inputs. So if you imagine we have got this function, so our cuboid volume, right, is going to accept height, width, and breadth, and the output is going to equal height times width times breadth. So what we can actually do then is we can actually run this function by passing it its required inputs, right? And this is how we would do it. Look here, for example. So cuboid volume 3, which corresponds to height, 4 corresponds to width, 5 corresponds to breadth, right? So that is a function application. So it's when you essentially are executing a function and passing it its inputs. So as well as function application, we can also have partial function application. So in this example, look, we've actually got a function called add. Add takes a parameter of x and y, and it returns the value of x plus y. So for example, we can actually use here add 3, 7 will actually give us the answer of 10, right? But what we could do is we could create another function and add 6, look, what we're going to do is we're going to partially apply add because we've only got one argument there, but add says we need 2, so we've only got 1. So what's going to happen then is when we actually run add 6, the argument for add 6 will actually be passed into the add function as the other value. So add 6 and the value of 10 will actually return 16. So it's only partially applied. Add is only partially applied here because there is an argument missing, but the input to add 6 is actually going to give us our additional argument. So function composition is the process of combining 2 or more functions to create a more complex function. The output is then actually used as the input for the next function. So the output from the first function is used as the output from the second. So imagine we've got these two. So function f is going to take the value of x and it's going to square it. Function g is going to take the value of x and it's going to add 3 to it. So what we can actually do then is if we pass the value of 4 into function f, we will square it and we'll get the value of 16. The 16 is then going to be put into our g function and it's going to add 3 to it to get to 19. So this notation here, so g.f, the dot here means composition. So a composition of g and f is exactly the same as writing, if you notice here, look, g is the outer function and the inner function here, look, is f. So f is the inner function, g is the outer function, and that's exactly the same way as writing x squared plus 3. So function composition is the idea that you can actually combine 2 or more functions to create a more complex function. So thank you very much for watching, and if you have any questions, you can contact me via Teams. That's through the chat or the call function, or you can actually email me. Thank you very much.